Thank you for this opportunity to present what Osazda has been doing. Osazda really means solar or sun in one of the tribal dialects here in New Mexico. So solar energy is the name of the company. And I don't know how many of you are from New Mexico or how many of you are from out of state, but if you were to travel from Albuquerque, which is a central New Mexico on Interstate 25 northbound, you will see these solar farms on the left and right as you travel towards Santa Fe. And what you're seeing typically in the field are what we call photovoltaic modules. They're about 5 feet tall, 3 to 4 feet wide, rectangular shaped panels. And within that panel, you'll see these blue square blocks, and those are the solar cells that are embedded in the PV module. So on the next, let's see, slide, this is what solar cell looks like when you magnify it. The blue region is what we call silicon substrate that generates useful electricity. And the white or gray lines that are running parallel to the substrate or the perpendicular to the substrate, those are actually silver metal grid lines, what we call metallization. And of course, solar cells produce useful electricity, but they have to be harnessed. They have to be collected. And so we use the metal grid fingers and bus bars, also known as metallization, to collect the useful electricity. However, it turns out that these cells are the metal lines are very susceptible to cracks along with the cells. So over time, I'm trying to move forward, but looks like it's not collaborating with me for some reason. Okay, so it turns out that these panels and cells have to last well over 25 years. So solar module manufacturing companies typically provide power warranty that lasts up to about 25 to 30 years. But of course, it has to weather through hailstorms, hurricanes, and whatnot. And so it really has to weather a lot of the stressors, environmental stressors. It turns out that those stressors tend to cause cells to crack. When the cells crack, they tend to sever the metal lines, and therefore you lose power. And so what we are trying to do, so here's actually a visualization of what cell cracks look like under load. So if you step on it, for example, installers may step on your panel, and the dark regions that appear on the screen represent the cell cracks and how you're losing power from those regions as the cell cracks propagate through the metallization. Okay, so this could really happen to you. It turns out that in East India, actually the animals stepping on your panels can cause cell cracks, which in turn can lead to power loss. So cell cracks over time get worse, and therefore the power generation from these PV modules they degrade and they become worse. And what we're trying to do is find a materials engineering solution to counter that power loss. So cell cracks are very small. It's not easy to see under the naked eye, but it's a big problem for solar module manufacturing companies, as well as the solar farm owners. They certainly lose power, and therefore they eat into their profitability. So we're trying to find a solution. And in our case, we took our inspiration from Gumby and try to make metal lines very stretchy. So let's say if the cell cracks really do happen and open up, can we actually make these metal lines very stretchy and therefore essentially crossing over the cell cracks and being able to maintain what we call electrical continuity? That is still being able to collect the electricity from the regions of the cell that are broken off. And so that is the sort of a conceptual idea that we came up with. And here's the graphical illustration of what we are trying to do. So those white or gray lines represent the metallization, metal grid fingers. And within these metal grid fingers, we embed very strong rebar structure, essentially, known as carbon nanotubes. So they're very strong, they're highly conductive, they carry lots of current, and here is the actual experimentally observed image. When you crack open the silver grid lines, that you can actually see these what we call carbon nanotubes that actually bridge this gap and being able to maintain electrical continuity. That is, even if the cells break, even if the metal lines break subsequently, we can bridge the gap electrically using carbon nanotubes, much like rebar in concrete structures. And so with that solution, certainly the degradation rate of PV modules will be slower. So what you're seeing here is on the y-axis, it's a revenue or expense axis, and x-axis that represents the operational lifetime. And so revenue obviously gradually drops as the modules degrade over time due to environmental stressors. But what we're trying to do is extend the operational lifetime by making the degradation rate slower. So given the normal expense line rising over time as the solar farms get old, that this gray area represents the extended lifetime and therefore increased revenue for the solar farm owners. So for typical $100 million farm, of a 100 megawatt farm, the net present value will increase by about $2.5 million. Of course, that's certainly a benefit for the utility farm owners, but also the cost of electricity will go down. So the consumers also benefit from lowered electricity cost. So with that in mind, currently we're following two business models. One is going full manufacturing, that is creating a silver paste where these carbon nanotubes are embedded. And we're going to sell this product to solar cell manufacturers who will subsequently supply the modules to solar farm owners. And the second model is a licensing model where we will license our intellectual property to silver paste manufacturers, making their product distinguishable from other currently available market products. And these paste manufacturers will subsequently sell their product to solar cell or module manufacturing companies. So, so far we have raised about $3 million in non-dilutive funding, and we're currently expanding our company by hiring a domain-specific CEO along with other engineers, and we're looking for investors at the moment. With that, I will end my presentation.
All right. Thank you. So Cecilia, now we are going to hand this off to our panel shark.
I'm also with Phoenix Ventures. This is Frank Levinson, and Avinash is here with me. So one of the questions we have is you know, what is the actual increase in cost for the silver plus carbon nanotubes versus the silver paste that they have now on a basis of the ink and also on a basis of the panel? How much extra cost does this engender?
Frank, thanks for asking that question. It's virtually imperceptible. That's the answer that I have. That is, we're adding so little carbon nanotubes. It's almost nonlinear response. We're adding very little to the silver paste and yet providing super strong mechanical properties and electrical properties. And therefore, with a very almost imperceptible increase in price, we're actually gaining a lot out of that product. And for exact number, Frank, actually, Dr. April Jeffries, who is the Director of Business Development for Osazda, is here with us, and she can actually give you the exact numbers today.
Sure. Hi. So for the direct materials cost, we use a very small amount of these carbon nanotubes. So in the solar industry, we normally talk about things in terms of dollars per watt. The direct materials cost only adds less than 1 cent per watt. We think that we can provide a large amount of value from our product for our downstream customers. So right now what we're trying to figure out is what is the premium that we can command based on the value added for our downstream customers. So although our direct materials costs are essentially the same, we think that we could probably charge a little bit more because we do add value in extended operational lifetime.
And is there any issue do you have to use sorted carbon nanotubes? Because not all carbon nanotubes are conductive, right? Or most of them are.
Correct. If you were to consider single wall carbon nanotubes, it could be semiconducting, it could be metallic. In our case, it turns out that we use the low cost, cheap carbon, multi-wall carbon nanotubes that go into tire manufacturing. They tend to work the best. And so it's actually a low cost material that we can purchase in bulk.
And how do you what's the plan to reach out to panel manufacturers? I mean, most of them are in Asia today. There are still a few here in the U.S.
Great question, Frank. Currently, we've been working with DuPont as our strategic partner, and because of IP issues, we've been very cautious approaching module or cell manufacturing companies. However, there are some companies that are placed in North America, such as Canadian Solar and whatnot, still owned by Chinese, but certainly North American manufacturing companies, and we're reaching out to them. April can fill you in on exactly the kinds of companies that we've been reaching out to and other stakeholders.
Yeah, so we haven't talked to a ton of solar cell manufacturers yet because of IP issues overseas. We have talked to solar panel or solar module manufacturers that are here in the United States, and one solar cell manufacturer that's located in North America. We've basically heard feedback that cost is extremely important. So quantifying the value added to the downstream customers is a necessary step. And yeah, we're starting to develop those relationships with the solar module manufacturers and silver paste manufacturers.
One more question. I don't know if you can see it, but you made it look like they were stringers, but in reality they must be randomly oriented. You don't.
Correct. Frank, correct. That's absolutely correct. The image that you're seeing is certainly magnified view of when you. Yes, the answer is right. They're randomly oriented, but if you look at the fractured surface, you can see the fiber pull out, and so that's when you stretch out the carbon nanotubes. Those are the image that you saw is essentially carbon nanotubes that are stretched out in or between the fractured surface. Yeah.
Do you have some sort of white paper that shows how this is that demonstrates its resiliency, or how have you stress tested this? I don't know, not having goats walk on it, I suppose. But
yeah, so yeah, we have published. Usually, our publications definitely trail where the company is, largely because we don't want to reveal too much and reveal just enough to tell the world that we can do this. But there are publications and presentations as well. And conference proceedings. We can certainly forward them to you after this meeting. Frank, we can certainly do that for you.